Once again we are here to discuss our topic number system. This is the part 7 we are going to discuss. First we are discussing here exponents of real number. Though you have read in your previous classes, 7th class, 8th class also, but I want to recall all those definitions. So here is exponents of the real numbers. Exponents, you know, that can be written in the form of parts. That is known as exponents, or we call them index numbers, or the plural form is what? Indices. So positive exponents. For any real number a, any positive integer n, define a to the power n as a to the power n. How can we write this a to the power n? We can write this a n times. A multiply a multiply a multiply a and so on up to a. This is n times. Or another example is there, 2 to the power 6. So 2 is the index form. This 2 we can write how many times? 6 times. 1, 2, 3, 4, 5, 6. So this is known as factor form. If we multiply this, all these 2, we get here 64. So this is the basic numeral. So this power form is index form or the exponents form, and this is a factor form, and this one is 64 is the basic numeral. For any non-zero real number a, if a to the power 0 is there, then we have a is equals to 1. Example, 5 to the power 0 is equals to 1. 3 upon 2 to the power 0, that is again 1. Whatever is the number, if the index form is 0, means power is 0, then always the answer is 1. I will explain this later on when we will read the laws of the exponents. Negative integer. For any non-zero real number a and positive integer n, a to the power minus n will make it positive integer by taking it in the denominator. A to the power minus n is equals to 1 upon a to the power n. Example, we can take it 3 to the power minus 4. So it becomes 1 upon 3 to the power 4. Or we can write 3 how many times? Again 4 times, because the power is 4. 3, 1, 2, 3, 4. When we multiply, we'll get the answer as 1 upon 81. Now the important things are there, the laws. Laws of the exponents, or we can say the indices, because index is the plural form of the index. An index number is a number which is raised to a power. The power, also known as the index, tells us how many times you have to multiply the number itself. So index means the power, which tells us that how many times you have to multiply the number itself. So first law is here, a to the power x. A is any number, x is the index of this a. Multiply, a is the same number and y is the index, but the indices are different and the base numbers are same. So when this multiply, then the power will add, a to the power x plus y. Example, we can see here 2 to the power 4 multiply 2 to the power 3. 2 base are same and the indices are different, the powers are different, 4 plus 3. So it becomes 2 to the power 7. Similarly, if we have any power as negative, 2 to the power 4 multiply 2 to the power minus 3. We are having here 2 to the power 4, but we have to add here. If the bases are multiplied, then the power should be add. 4 plus minus 3. But because of this minus algebraic, this is the algebraic term here. So plus minus becomes minus. So 4 minus 3 is equals to 2 to the power 1 is the answer. Similarly, the next law is here, a to the power x divided by a to the power y. If the same base but the indices are different, they are divided, the power will subtract and the common number will come here. A to the power x minus y. Example, 2 to the power 8 divide sign 2 to the power 4. Both will subtract, 2 to the power 8 minus 4. It becomes 2 to the power 4. Similarly, 3 to the power 2 divide sign 3 to the power 5 is equals to 3 to the power 2 minus 5 is equals 3 to the power minus 3. When we'll make it positive, it's come in denominator 1 upon 3 to the power 3. Next property is there, a to the power minus x is equals 1 upon a to the power x. Means negative power. This property has come from this previous question, that it is written here a to the power minus x is equals to 1 upon a to the power x. If here is negative, it becomes positive. 3 to the power minus 3, it becomes positive. 1 upon 3 to the power 3, 1 upon 27. 3 to the power minus 3, 1 becomes 1 upon 3. Next property is there, a to the power x to the power y is equals to a to the power xy. Example is we can take here, if power has power, two powers are here outside the brackets, so both the power will multiply. A to the power 6 is the example. 3 to the power half to the power 3. So this 3 is multiplied to the numerator of the index number. 3 to the power 1 upon 2 into 3, so it becomes 3 to the power 3 upon 2. The next property we are having here, a multiply b. The base are different, the power is common. So this power will divide to both base numbers, a to the power x multiply b to the power s. Example is given, 3 multiply 2 to the power 2, 3 square multiply 2 square, 3 square becomes 9 and 2 square becomes 4, that is 36. Next property is there, a to upon b to the power x. Both it is similar like this, because if the number are multiply or divide and they have the common power, the power will divide for both, a to the power x upon b to the power x. Example, 3 upon 2 to the power 2 is equals 3 to the power 2 upon 2 to the power 2. It becomes 9 upon 4. One example is here, if a is equals to 3 and b is equals to 4, then we have to evaluate a to the power b plus b to the power a. A, what number is a? 3. 3 we have written. Power is b. What is b here? 4. 3 to the power 4 plus b is here 4. 4 to the power 3. It becomes 81 plus 64, that is 145. So like this we can solve the questions. Now the important thing is there rational exponents of a real number. If a is not equals to 0 and n is any positive integer, then nth power of a is equals a to the power 1 upon a. These are known as surds. 3 to the power under root 2. Under root, this is a surd. So 2 to the power 1 upon 3. You know this, you are familiar with this. So nothing is new for you. 4 root 2 is equals to 2 to the power 1 upon 4. Means we can say that nth root of a means 1/3. This is the third root of 2. Fourth root of 2. Like this we can say. Now if a is not equals to 0. If a is not equals to 0 and p upon q is a rational number, then q is greater than 0. If a is not equals to 0, p upon q is a rational number and q is greater than 0, then a to the power p upon q is equals to a to the power p will remain inside the bracket and outside there is a surd. Like this, 2 to the power 1 upon 3. So this becomes here 1 upon q. Means we have, I just want to tell this thing to you that these properties, these law, what we have done here, these we can use from both the sides. Means a to the power x multiply a to the power y can be written as a to the power x plus y. But if anytime we have this number, so we can, according to the demand of the question, we can write this number a to the power x plus y like this one. Means these all laws we can use from both the sides. Means a to the power x, a to the power y is equals to a to the power x plus y, and also a to the power x plus y is equals to a to the power x multiply a to the power y. Similarly with negative a to the power x minus y, if it is given according to the question, we can write this number as like this, a to the power x divide sign a to the power y. Means all the laws we can use from both the sides, either left side or the right side, according to the demand of the question. Now these are some examples. 32 to the power 1 upon 5, 27 to the power minus 1 upon 3. So first we will discuss here 32 to the power 1 upon 5. This 32 can be written as 2 to the power 5. This factor we can take according to this method. You know about this, a to the power 32, a 2, 32, this 16, a 4, 2. So we can write 2 to the power minus into 1 upon 5. This 5 can be cancelled out. So 2 to the power 1 is equals to 2. So this is the answer. Similarly with second example, 27 to the power minus 1 upon 3. So 27 can be written as 3 to the power 3 minus 1 upon 3. Can be cancelled out. So this becomes 3 to the power minus 1. So we can make it positive by taking this power to the denominator. 1 upon 3 to the power 1, it becomes 1 upon 3. Similarly the third example. So you can solve this. More example on this. Under root 9 to the power minus 2 is equals 9 to the power half to the power minus 2. This 9 can be, root 9 can be written as 1 upon 2 and outside power is minus half. So these two powers can be multiplied according to the law of exponents. So 2 can cancel, minus 1 is equals to 1 upon 9. Cube root of 64 to the power minus 2. 64 can be written as, this will be 1 upon 3 to the power minus 2. So again both the parts will multiply. So this 4, according to this 3, 64 also can factorize in 2. But here according to the question we are having here 3. So we will factorize this in the form of 4. 4 to the power 3 multiply 2 upon 3. So this 3 can be cancelled. 4 to the power minus 2 is equals to 1 upon 4 square. It becomes 1 upon 16. Now here is one more question. One example is different kind of question is here. Write the following irrational numbers in ascending order. 3 root 2, 6 root 3, 9th root of 4, this one. So I am explaining here, and the second one is for your practice. 3 root 2. So first of all we will check their roots. 3, 6 and 9. So what is the order of roots? 3, 6 and 9. We will take their LCM. 3, 6 and 9 becomes 18. The LCM will be 18. So we will convert each root into order of 16. This 3, this 6 and 9. We will multiply by some number that they will become 18. 3 root 2. So this 3 will become 18 if we multiply it by 6. So this 2 to the power, we can write here 1 upon 3. This 1 upon 3 we want to make the denominator as 18. So we will multiply numerator and denominator by 6. So this becomes 6 upon 18. Similarly, so 18 will come out because this is a root. This root 3 root is converted here in 18 to the power 6. 6 root 3. So this 6 we want to make it 18. So multiply by 3. So it becomes 3 to the power 1 upon 6. 3 to the power 3 upon 3 was there. So this is 3 upon 6. This one is 6. Here is 6. We multiply by 3. This becomes 3 upon 18. So 18 will come in again root. So 3 to the power 3. It becomes 18th root of 27. 9th root of 4. Similarly, it becomes 18th root of 4 squared, that is 16. Now we will check these numbers which are in roots. 16 number, 27 and 28, 128. So 16 is here is less than 27 is less than 128. This number means 18th root of 16 is less than 18 root of 27 is less than 18 root of 120. This number indicating which number? 18 root 16 indicating 9th root of 4. So this is here. 18th root 27 indicating which number? 6th root of 3. This is here. And the last number is 3 root 2. So this is the ascending order. Similarly, we can simplify the example. 6m square, 10m to the power 14, 3m to the power 10, 2m to the power 6. So this number 6 and this number 10 will multiply together. And m square, m to the power 14 base are same. They are multiplying. Their power will add. Again 3 and 2 will multiply. And m to the power 10, m to the power 6 they will add. So 60 upon 6, m to the power 16, m to the power 16 both will cancel out. Means cancel out, or we can cancel them. So we'll have here 1, or they are divide. So their power will be subtract. We can write like this: 60 upon 6 multiply m to the power 16 minus 16. So it becomes 0. That is 10 into 1. The 10 is answer. 2 to the power n. Another example: plus 2 to the power n minus 1, n power plus 1 minus 2 to the power n plus. So this 2 to the power n, I told you in previous one, first one, that what we can write, we can use this to this side, this to this side. Negative means the power, or the plus 1 can be write like this. So here we have change. This is 2 to the power n multiply 2 to the power minus 1. We have written it like this: 2 to the power n, 2 to the power 1 minus 2 to the power n, 2 to the power n from here, and this can common. In denominator also this can common. Here is written 1, nothing is remaining, 1 is remaining. 2 to the power minus 1. Here is 2 minus 1. This can be cancelled out. 1 plus, to make it positive, 1 upon 2, 2 minus 1. Taking their LCM, and we are having 1 upon 1 plus 1 upon 2. This becomes 3 upon 2. This question is for your practice.